We began our exponent rules today. So exponents, just a quick recap for them, are repeated multiplication, they're comprised of two parts. So if we have 3 to the 4th power, the 3 is known as the base, 4 is known as the power. That's telling us we're going to take 3 and we're going to multiply it by the number of times listed in the power. With all things math, once you introduce a new system, we have to make sure it fits within the old system. And that helps us with our concept of, with our product rule here. When two terms with the same base are multiplied, the exponent powers happen to be added together. So the keywords here are same base, so they have to be the same big number. The bases have to be multiplied together. Once those two criteria have been met, we take the exponent powers and they're added together. So 4 squared times 4 to the 3rd, they're both 4s. They're being multiplied. So we end up taking the 2. We can add the 3 for our answer of 4 to the 5th power. Same is true when we have variables, say x squared times x to the 5th. Same base. They're being multiplied. So we're going to add the two powers together. We get x to the 7th. Reason why the product rule works the way that it does is x squared times x to the 5th really looks like this. So that's the x squared. That's the x to the 5th. And it's really just an extension of the multiplication. If we have coefficients in front, the 3 and the 4 are not the same base, but that just means they don't apply the product rule. We're not allowed to add the exponent powers of 1 and 1. When we have coefficients, the coefficients are going to follow the operation in the middle just like they normally would. If we rewrite this using our commutative property, 3x squared times 4x to the 8th is really 3 times 4 times x squared times x to the 8th. So 3 times 4 gives us the 12. 2 plus the 8 gives us x to the 10th. There's our answer. If we happen to have a negative exponent, doesn't change anything. 5 times the 3 gives us 15. And then 2 plus negative 1 gives us a positive 1. If we happen to have more than one variable, 6x cubed y to the 5th times 10x squared y to the 12th, we're only going to worry about letters that are the same. So the 6 and the 10, granted they're not the same number, but since they're both coefficients, just regular numbers, we're going to take the 6 times the 10 and get 60. We're going to take the x's, x cubed times x squared, so that gives us x to the 5th. Then we're going to finish with our y values. We get y to the 5th times y to the 12th. We add those together, we get y to the 17th. Product rule. The next rule is the quotient rule. It's kind of the opposite of the product rule. When two numbers are the same base, so same criteria, have to be the same, but this time are divided, the powers are subtracted, top minus the bottom. Alright, so both are x's being divided. We're going to take our top power, we're going to subtract the bottom power. We get x to the 4th. How the quotient rule works is I have my 7 x's across the top, got my 3 x's across the bottom, and then anything divided by itself ends up getting canceled out. So 3 of the x's on the bottom and 3 of the x's on the top cancel out, leaving 4 x's left for x to the 4th. If we have multiple letters, it's the same thing. We're only going to worry about the similar letters. So the x's will go with x's, the y's will go with y's. 5 minus 2 gives us x to the 3rd. Y cubed minus 2 gives us y to the 1st. And there's our answer. Now that we have the quotient rule, we can actually take a look at what happens when we get a positive and we get a 0 and a negative exponent. So 0 exponents always equal 1. So x to the 0 is 1. Why that's true is if I have x squared over x squared, the quotient rule says I'm going to take the top power minus the bottom power. But general mathematical rules say that anything divided by itself, say 25 divided by 25, is always 1. So these two ideas have to be identical. Then with negative exponents, they're repeated division. So repeated division. So you can kind of look at this pattern. 2 cubed really means 2 times 2 times 2. 2 squared is 2 times 2. 2 to the 1st is 2. Each rung in the ladder here, we're dividing by 2. Dividing by 2 each time. So we get to 2 to the 0 power. We have taken 2 divided by 2. So let's put it up here. And that's why we get 1. Continuing into our negatives, we're dividing by 2, and we end up getting 1/2. Big thing to remember about negative exponents is if they're negative on the top of the fraction, we move them to the bottom to become positive. If they're negative on the bottom, we move them to the top to become positive. So taking a look at our problem here, we have the y's. Y to the 4th minus y squared gives us y squared, still on the top of the fraction. Now with the z's, I take the 3 minus the 4, and we end up getting z to the negative first power. We will never leave a negative exponent. So if it's negative on the top, we move it to the bottom. We can see this answer within the problem itself. So because the final answer is y squared over x to the first, what it's saying is that there are two y's left over on the top. So if I take out these two y's, I can take out these two, and I'm left with 2. I take out these 3 of these go with it, I'm left with 1 on the bottom. If we have coefficients in front, they simplify like fractions. 3 goes into both of these. 1 time for this one, 2 times for that one. So 1 over 2 for our fraction. X to the 5th minus 7 means I have negative 2 for my power. We will never leave a negative exponent. So since it's on the top, it gets moved to the bottom. We can see the leftover x's within the problem itself. There are more x's on the bottom. Now adding in negatives to the initial part of the problem. X to the 4th, y negative 2, so w to the 5th, it's negative 5th there, and let's say w3, x to the 1st, y to the negative 2. Quotient rule says we're going to take the top power, subtract the bottom power. So I have negative 8 w's. 4 minus 1, so I have 3 x's. Negative 2 minus negative 2. These two minuses become plus. So that actually becomes y to the 0, which actually cancels out. We will never leave a negative exponent. So since it's negative on the top, it gets moved to the bottom. And that brings us to our final rule. Final rule being the power rule. The power rule says that when one power is raised to another power, the two numbers end up multiplying. So this 2 multiplies the 3, and we get 6. This applies to all powers. So in a problem like this, we definitely see that the 2 should multiply the 2. The one that's harder to see is that it should actually multiply the 1 that's on this 3. The reason why we have to include the 3, if I were to write this out in expanded form, so 3a squared squared, this 2, let's make this actually for explanation purposes, let's make this a 3 instead. All right? The 2 means I have this, a times a, if I were to split that a into its pieces. This 3 on the outside means that I have 3 sets of parentheses. I have 3a times a, 3a times a, and I have 3a times a. So we see that this 3 equally affects a's as much as it does our coefficient of 3. So 1 times 3 gives us 3 to the third. 2 times 3 gives us a to the sixth. And that's actually what we see. We see 1, 2, 3 threes. Oops. And then we see 6 a's. So 5 x to the fifth, y to the third, to the fourth power. That 4 applies to the 3. It applies to the 5. But it also applies to the 1 that's on our coefficient. 5 to the fourth, x to the 20th, y to the 12th. Then we should take 5 and actually multiply it out 4 times, and that gets 625 as our coefficient. It's equally as true if our variables are written as a fraction. The 2 goes to every single little power, because we're basically taking this parentheses and repeating it twice. So we get x to the sixth, y to the fourth. If we have negatives, nothing changes. The 4 is going to multiply every single power. At the end of our problem, we have to make sure that all negatives have been moved to their correct location. So in this case, 3 to the fourth is 81. Y to the 12th stay on the top. The x moves to the bottom. And if we have 2x squared to the negative first power, the negative causes both of the terms to have a negative exponent, which means both terms get moved to the bottom of the fraction, and we put a 1 placeholder in the numerator.